This is Kasturi Day. Today I'm going to start a new chapter on chemistry, that is language of chemistry, according to ICSE syllabus class 8. Okay. So first we come to the chemical symbols of the elements. Okay. So what is a symbol? A symbol is a shorthand representation for an atom, okay, of a specific element. The atom, one atom of a specific element is represented by a shorthand uh, what do you say, shortened symbol, I mean shortened uh, structure, that is known as a symbol. Okay, each element has its own unique symbol. Okay, each chemical element, they have each identifying symbol, okay, unique symbol. Then qualitative meaning of a symbol and quantitative meaning of a symbol. What is the qualitative meaning of the symbol? It is a symbol represents a specific element. For example, say S. S represents the element sulfur. Capital S. Capital S represents the element sulfur. And a symbol represents one atom of an element. That is, S represents one atom of sulfur. Okay. So, qualitative meaning that it represents the element of sulfur, the element of the specific element. It represents a specific element and it represents one atom of that specific element. Okay. Now we come to quantitative meaning. What do you mean by quantitative meaning of the symbol? A symbol represents the mass of the element equal to its atomic mass. Okay, mass of the element, that means the equal to, that is its atomic mass. It represents the atomic mass of that element. Okay, for example, sulfur is, S represents how many times it is heavier than atomic mass unit. Okay, how many times it is heavier than the atomic mass unit. What is atomic mass unit? It is defined as 1/12 of the mass of carbon. Atomic mass defines that it is the 1/12 mass of carbon atom. In the present case, sulfur atom is 32 times heavier than 1 AMU. What is that AMU? AMU is atomic mass unit, and hence its mass is 32. Its atomic mass of carbon atom, sulfur atom is 32, as it is 32 times heavier than 1 AMU, and 1 AMU means 1/12 of the mass of carbon atom. Carbon atom has been considered as a standard atom. Okay. Now, by the beginning of the 19th century, 26 elements were known. Okay. In the beginning of the 19th elements were known to us, which increased about to 81 century. In the 20th century, this 26 elements, due to the more discovery of elements, it became to 81. Okay, as more elements were discovered, the number of symbolic representation of these elements became more evident. Okay, it became necessary to represent these symbols, to represent these elements by symbols. Okay, in the 19th century, a Swedish chemist who was known as John Jacob Berzelius systematically assigned the first letter of the name, and that was in the capital as the symbol of the element. Okay, the first letter of the name. For example, say oxygen. Oxygen was represented as O, capital O. Then hydrogen for H. Okay, so this later on formed the basis of the IUPAC system of chemical symbols and formula. I'll later discuss this IUPAC system in higher classes. Okay, so IUPAC system is a system of naming the elements through symbols, chemical symbols and formulas. Okay, so through this, the basis of this naming by IUPAC system is the letter, that is a representation of the elements through the first letter of the name. Okay, by this symbol. Okay, the first letter of the name is considered to be the symbol of the elements. Okay, which was first found by John Jacob Berzelius. He was a Swedish chemist. Okay, next we come to chemical symbols of the elements, each element is denoted by a symbol. Each element is denoted by a symbol, which is usually the first letter of its name in the English or Latin, which is written in capital. Okay, the first letter is written in capital. It is either, it may be an English letter or it can be Latin letter. Okay, so for example, oxygen is an element which is written as capital O, etc. Now, when the first letter of more than one element is the same, okay, when there the name may be different, but the first letter may be the same for two elements or more than that, the symbol is denoted by two letters. That time what happens, we denote the symbol by two elements. The first letter is written as capital and the following letter, okay, while the second is written as small letter. For example, see, carbon, cobalt, calcium, chromium, chlorine, all these have the first letter as capital C. Okay, so for carbon, we tell it, we give the symbol as capital C. For cobalt also it's C, but here we write as CO, capital C, small o. For calcium, it is written as Ca, capital C, small a. For chromium, it is capital C, then small r. For chlorine, it is capital C and small l. Okay, like this. Then these symbols also represent an atom of that element. Okay, I told you that by qualitative method, it denotes that this symbol also denotes one atom of that element. Okay, for example, H, capital H represents the element hydrogen as well as one atom of hydrogen. Then carbon, for carbons, capital C represents the the element carbon as well as one atom of carbon. Okay, some symbols have been taken from the names of the elements in Latin, German and Greek also. Okay, for example, say symbol of iron, it is written as Fe from its Latin name ferrum. Okay, then sodium, for the name of sodium, symbol is Na, capital N, small a, for the from the name natrium. Okay, therefore each element has a name and a unique chemical symbol. Okay, next is, see, the name of the element, the symbols are given and their Latin names. Okay, for example, gold, it's written as capital A, small u for aurum. Then silver, Ag for argentum. Then mercury, it's Ag, hydrogyrum. Copper, Cu, cuprum. Lead, Pb, plumbum. Iron, Fe, ferrum. Sodium, Na, natrium. Potassium, K, kalium. Tin, Sn, stannum. Okay. Then for the usual English names, that is magnesium, Mg, aluminium, Al, calcium, Ca, chromium, Cr, manganese, Mn, cobalt, Co, nickel, Ni, zinc, Zn, silver, Ag, barium, Ba, tungsten, W. Okay. Then platinum, Pt, radium, Ra, uranium, U, helium, He, argon, Ar. Then for hydrogen, H, nitrogen, N, oxygen, O, fluorine, F, chlorine, Cl. Then bromine, Br, iodine, I, carbon, C, sulfur, S, phosphorus, P, boron, B, silicon, Si, germanium, Ge, arsenic, As, antimony, Sb, then neon, that is Ne. Okay. Then we come to valency. Valency, what is valency? It is the combining capacity of an atom, of an element or of a radical with the atoms of other elements or radicals to form molecules. Okay, so atoms, they cannot stay alone. Okay, they need to combine with one more atom or a radical to form a molecule, to stay independent. So how many, that is the combining capacity, how many atoms or how many radicals will combine with one atom of an element to form the molecule, that is known as valency. Or it is the number of hydrogen atoms which combine directly or indirectly with one atom of an element to form a compound. Okay. Then you can say that the number of hydrogen atoms which is combining with one atom of an element to form directly or indirectly to form a compound, that is also called a valency. Or you can say it is the number of hydrogen atoms that will combine with or displace one atom of that element or a radical, that is also called a valency. Okay, for example, the valency of hydrogen is taken as 1. In HCl, one atom of chlorine combines with one atom of hydrogen. That becomes the valency of chlorine is 1. In H2O, one atom of oxygen combines with two atoms of hydrogen. Therefore, valency of oxygen is 2. In NH3, one atom of nitrogen combines with three atoms of hydrogen. Therefore, valency of nitrogen is 3. In methane, CH4 methane, one carbon atom combines with 4 atoms of hydrogen. Therefore, valency of carbon is 4. Okay. Therefore, there's a note that the valency of an element increases from 1 to 4. It increases from 1 to 4. Again, it decreases to 1. For some of the elements like helium, neon, argon, the combining capacity is 0. It cannot combine with other atom because they are inert gases and their outermost shell is complete. It has 8 electrons in its outermost shell. Therefore, it cannot combine with other element or other atom to form a compound or form a total molecule. Okay, so they are inert gases and they have the combining capacity that is 0. Okay. So I'll stop here. I'll continue with the rest of the chapter in my next video. Please go through this. If you have any doubt, please do write in the comment box. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And also do subscribe to get the notification of my next video. And probably today I will also give a video on electricity question answer series. Okay. And next video will also be this one, language of chemistry. Okay. Thank you so much. Thank you for watching.